previous lectures, we have seen that in order to properly describe the rotation of a solid object, we need to introduce some new concepts. We introduced the moment of inertia of an object about a pivot or one axis of rotation. This moment of inertia plays the role of inertia that played the mass in linear motion. It quantifies the opposition of an object to a change in its rotation, or in other words, how much an object opposes to an angular acceleration. We also introduced the torque as a magnitude that needs to act upon an object so that this object changes its rotation. In other words, the torque is the one that induces an angular acceleration onto an object. When we talked about the motion of a point particle, we introduced Newton's second law, Newton's laws in general, which describes how a force acting on a particle induces an acceleration on it. But when we talk about solid objects, we need to talk also about the torque and angular acceleration. We can say that here, in rotational motion, the moment of inertia plays the role of the mass played in when we were talking about the motion of a point particle. The angular acceleration here plays the role of the acceleration in the point particle motion, and the torque here plays the role of the force in the point particle. Here we also have an equivalent equation to Newton's second law. This equation states that the total torque acting on a solid object is equal to its moment of inertia times its angular acceleration. Tau is equal to I times alpha. From now on, when we want to describe the motion of a solid object, we need to account for Newton's second law and also for this extension of Newton's second law applied to rotational motion. Let's see this in an example. Let's consider a pulley. This pulley has a mass m0 and a radius r. From this pulley, we hang one rope and two masses from the rope. Let's assume that one mass m hangs from the right of the pulley at a distance r, and another mass 2m hangs from the left at a distance r. Because of the larger mass, the system will start to move. The 2m mass will move down, the m mass will move up, and the pulley will rotate counterclockwise. All objects will accelerate. We now want to find this acceleration. To calculate this, we need to apply Newton's second law and extension to Newton's second law to rotational motion. Applying Newton's second law to the two blocks, we get that weight 2 minus tension 2 is equal to 2m times